Hello and welcome to another video on the normal distribution. So again, how do we calculate the normal distribution between values? Well, for example, to find an IQ between 120 and 130, which is here, we would just type this in our calculator with a lower bound and an upper bound, the mean and the standard deviation, and would get the probability. And hence I would conclude that the probability of finding somebody with an IQ between 120 and 130 is 0.0918, the three significant figures. Here's the first important question. How do I find out the probability of finding somebody with an IQ over 120? Now, what is the upper bound then? What do I have to put here? I'm simply going to put a big number. Any really big number. And this is the one we're normally going to put in. 10 to the power of 99. And that's going to work. That's going to tell us the probability of finding somebody with an IQ over 120. So here's a person throwing the javelin for the school's team. Her average mark of the year is 30.2 and the standard deviation is 3 meters. So what's the chances of her throwing more than 32 meters? Well, I tap in the values in the graphic display calculator. And for upper bound, I'm going to put 10 to the power of 99. So when I paste it, I calculate the probability to be 0.274. That's the probability that Joanna throws the javelin more than 32 meters. Great. And what are the chances of her throwing less than 27 meters? Well, I need to put no lower bound. The upper bound is going to be 27, and the lower bound is going to be a very small number. This is what I put in the GDC. Now notice that this minus 10 to the power of 99 is just a very big negative number. And that's what I put for the lower bound, not the upper bound, sorry, the lower bound. So I get the probability to be 0.143. That's an important thing. That's how we calculate bigger than and smaller than values. And we're going to use what's probably one of the hardest things with the normal distribution, which is the inverse normal distribution. It's another function in the calculator. And how do we use it? Sometimes they give us the probability. And they want us to calculate where that probability might happen. From where to where is that probability? Now, I have a function for that. It's an invNorm function. And this is the way it works. Now, suppose we have a probability of 0.25. Now, first thing to realize, a probability of 0.25 could happen in many places. For example, here. This is again my IQ, but it could happen here. It could also happen here. And why not? It could also happen somewhere random in the middle. Like, we need to find out where this probability is. And actually, they're going to let us know when they ask us the question. But first of all, how does the calculator know? Well, let's learn how to use the function itself in the calculator. We have the invNorm function, right? And suppose that, let's just put 0.25 and let's see what it gives us. So I go to invNorm, I go to the distributions menu, choose option 3, which is invNorm, and put the area 0.25. I put the mean and the standard deviation for the IQ normal distribution. I press paste, and this is what I get, 86.51. And actually, what is this telling us is this value here. So when I use the invNorm function, it systematically is going to tell me the probability of finding an element smaller than that value. Smaller than that value. The probability of finding something smaller than 86.51 is 0.25. That's systematic what the invNorm function is going to be giving us. So again, here's another example. This is a bit more elaborate, but I have the average consumption of an apartment in a building and the standard deviation. And I want to offer a plan that 60% of the people like. So that is designed for them. So what does the 60% of the people consume? What is like the 60% that consume less? What is the most they would consume? Well, we define the normal distribution, and the probability that somebody consumes less than the value we want must be 0.6. That I pick somebody who lives in the community and they consume less than that must be 0.6. So it's in the right form. It's smaller than that value. The probability is 0.6. So I go to the calculator, I put it in, and I get it. 8253.347. There you go. Simple. So